The frigid expanse of space, veiled in eternal darkness, holds countless enigmas. Yet on the 10th day of October in the year 2025, one of its secrets unveiled itself unexpectedly. While Earth's inhabitants were preoccupied with terrestrial concerns, the Tanwen-1 satellite, silently orbiting the red planet for years, pierced the cosmic silence like a sudden spark. Its precision camera, originally calibrated to map Martian landscapes, abruptly detected an elusive entity, hurtling through the void with astonishing velocity. This was no ordinary comet. It was a messenger from the primordial vastness of interstellar space, bearing questions that defied easy answers and challenged the boundaries of human understanding. The scientific community's attention sharpened at the sheer peculiarity of this visitor. The object approached the Sun at a staggering 58 kilometers per second, over double the speed of any previously recorded interstellar traveler. In mere minutes, it could traverse the distance between Earth and its lunar companion, a feat that underscored both its formidable momentum and the urgency with which researchers sought to unravel its origins. Measuring just 5.5 kilometers in width, roughly equivalent to the span of New York City from river to river, the object seemed almost trivial in scale. Yet its isolation at a staggering 18 million miles from the Tanwen-1 rendered it an enigma shrouded in distance. Despite this vast separation, the satellite's advanced instrumentation captured precise measurements and striking imagery. These initial findings, disseminated over the following hours and days, ignited a cascade of perplexity among astronomers and astrophysicists. How could such a minuscule body achieve such velocity? What cosmic forces had propelled it across light years to traverse the solar system? The data, both awe-inspiring and confounding, demanded scrutiny, revealing not only the object's physical characteristics, but also the limits of current observational technology. Each photograph and dataset became a thread in a larger tapestry of uncertainty, inviting speculation about the nature of interstellar wanderers and the invisible currents that guide them through the universe's infinite reaches. In its fleeting journey, the comet became a symbol of cosmic unpredictability, a reminder that even in an age of advanced exploration, the universe retains the power to astonish. Its passage, swift and unexplained, left scientists re-examining assumptions, piecing together fragments of evidence to decipher a story written in the language of stars. The most striking initial observation centered on the complete absence of the traditional tail structure. Standard comet models, grounded in decades of astronomical study, predict that such an object passing close to the Sun should generate a conspicuous tail. Driven by the relentless pressure of solar radiation and the ceaseless stream of charged particles, known as the solar wind, this tail would extend dramatically behind the central nucleus. Furthermore, having traversed the inner solar system and suffered a staggering loss of more than 13% of its original mass, the object was expected to transform into a brilliant, luminous feature. It should have been accompanied by a visible halo of disintegrated particles and vaporized ice, creating a spectacle. Instead, the camera aboard the Tanwen-1 probe recorded only a diffuse, featureless glimmer, a formless light spot devoid of any discernible structure confirming the presence of a classic comet nucleus or its tail. It was as if a vast frozen world, poised to unveil its secrets, had abruptly become an impenetrable shadow, refusing to interact, refusing to yield to the Sun's intense heat and radiation. However, this enigmatic appearance was merely the opening chapter of a far stranger story. Within days of the close encounter,
researchers uncovered a series of additional, profoundly anomalous phenomena, each more perplexing than the last. While the loss of the tail stood alone as a significant deviation, it was the sheer convergence of multiple, unusual characteristics and behaviors that transformed mere improbability into near impossibility. The cumulative effect of these 10 distinct and unexpected observations rendered the hypothesis of random error or isolated anomaly statistically negligible. For instance, the object's trajectory defied all established gravitational prediction models. Its movement showed no discernible pattern or adherence to the expected paths governed by the known laws of celestial mechanics. Simultaneously, spectroscopic analysis revealed a composition utterly alien to any historical record. Its spectral signature bore no resemblance to the chemical makeup of any known comet catalogued over the preceding millennia. As the volume of data grew, each new measurement only served to deepen the mystery, the object's behavior becoming increasingly resistant to explanation. The physical evidence seemed collectively to resist interpretation, as if the fundamental principles of physics themselves were attempting to avert their gaze from the inexplicable reality unfolding before them. Nothing could explain why this enigmatic object, which was expected to plunge into a catastrophic race with the sun and become a dazzling spectacle, opted instead to remain hidden, elusive. None of the tools humanity had relied upon to measure, analyze, or categorize cosmic phenomena could offer answers. Even the most carefully guarded hypotheses, whether they suggested a random anomaly or a data error, gradually crumbled under the weight of irrefutable evidence. What unfolded on that October day, as the object orbited perilously close to the sun, defied even the most imaginative scenarios.
Its behavior transcended the boundaries of familiar analogies, leaving scientists and astronomers utterly perplexed. When the data were meticulously reviewed and cross-verified, they stood as the sole testament to a reality that transcended conventional understanding. This phenomenon, which lacked a name but already compelled researchers to reconsider the very foundations of cosmic knowledge, lingered in collective memory as a moment when the universe abruptly ceased to make sense. Our modest planet, accustomed to the comforting predictability of celestial order, discovered that beyond the veil of the visible there lay something profoundly transformative. A force that challenged not only our perception of the cosmos, but also the limits of human imagination. The Chinese Space Agency faced a challenge that seemed insurmountable. Tracking an object barely larger than a small town, its surface dark as asphalt, hurtling through space at a velocity that surpassed all known natural phenomena within the solar system. Its trajectory, unlike any previously recorded, demanded unprecedented technological innovation and collaboration. The sheer scale of the endeavor tested the boundaries of existing observational capabilities, forcing scientists to rethink methodologies and assumptions about interstellar travelers. This silent intruder, moving with an otherworldly speed and obscurity, became a symbol of the profound mysteries that still linger just beyond our grasp, waiting to be unraveled by the relentless pursuit of knowledge. Despite the comet, designated 3I Atlas, residing at a considerable distance of 30 million kilometers from Earth, Chinese specialists maintain strict silence regarding their ambitious objectives. They only unveiled their successful findings on November 5th, images which sent ripples of astonishment through the astronomical community. The public release comprised black and white footage that clearly depicted a fuzzy spherical celestial body enveloped by a diffuse cloud-like formation, the comet's coma. Scientists specified that this ethereal envelope stretched across several thousand kilometers, a testament to the comet's volatile nature. These visuals were officially heralded as a significant technical achievement. They represented a crucial experiment within the broader framework of preparing for future missions, venturing into the profound depths of space. Yet beneath this formal declaration lay a discovery of far greater magnitude. The historical significance of the data was undeniable. These constituted the closest-up photographs of Comet 3I Atlas ever captured by humanity. Not even the renowned Hubble Space Telescope, nor the cutting-edge James Webb Space Telescope, and certainly no terrestrial observatories had ever approached this comet so closely.
While the European Mars Express orbiter and the Trace Gas orbiter had also observed the comet as it passed perilously close to Mars, the unique data set gathered by the Chinese spacecraft surpassed any expectations for detail and proximity. However, the most astonishing revelation emerged from the meticulous analysis of these unprecedented frames. Scientists found themselves confronted by an unexpected absence. As comets journey towards the Sun, their surfaces heat up significantly. This thermal energy causes the long frozen gases and volatiles trapped within the comet's nucleus, relics from the primordial era of the solar system solidified billions of years ago, to sublimate, transforming directly from solid to gas. This process is fundamental and universally expected. What astounded the researchers, however, was the conspicuous lack of this anticipated activity on the comet's surface as depicted in the closest images ever obtained. Solar wind, comprising a continuous stream of charged particles ejected from the Sun, exerts significant pressure on material surrounding a comet nucleus. Concurrently, intense solar radiation provides the energy necessary to vaporize volatile substances like ice and dust from the comet's surface. Together, these powerful solar forces act to expel this liberated material away from the Sun, sculpting it into the characteristic glowing tail that typically extends millions of kilometers through space. Furthermore, this tail's luminosity generally increases as the comet approaches the Sun and its temperature rises, making the structure more conspicuous to observers. However, detailed observations captured in specific photographic records revealed a surprising absence of these expected tail features associated with Comet 3I-Atlas. This notable lack of a prominent bright tail implied either that the comet possessed an exceptionally atypical chemical makeup compared to more familiar comets, or that its interaction with the Sun's intense radiation and particle stream operated through mechanisms distinct from those governing other known celestial bodies within our solar system. Consequently, these observations served not only as a demonstration of the meticulous scientific rigor and technical proficiency exhibited by the involved specialists, but also introduced profound new enigmas regarding the fundamental nature of distant interstellar visitors like Comet 3I-Atlas. These findings underscored that significant questions about the composition and behavior of such cosmic entities remain unresolved, demanding further investigation and study to achieve a clearer understanding of their unique properties.
Upon reaching its closest approach to the Sun on October 30th, Comet 3I Atlas traversed a perilously close orbit, situated merely 0.9 astronomical units from our star. This proximity placed it even nearer than Earth's own path at times, and closer than Venus during specific segments of Venus's journey around the Sun. Data meticulously analyzed by NASA's Jet Propulsion Laboratory revealed an astonishing phenomenon within the comet's trajectory. The path of 3I Atlas exhibited unmistakable non-gravitational acceleration, a distinct deviation from the expected motion governed solely by solar gravity. This acceleration stemmed directly from the comet itself, propelled by the measurable force of its own outgassing. The calculations derived from these observations yielded precise figures. At a standard distance of 1 astronomical unit from the Sun, the comet demonstrably experienced a radial acceleration of 1.1 times 10 to the power of -6 astronomical units per day squared. This force acted directly outward, pushing 3I Atlas away from the Sun's center. Furthermore, the data indicated an additional transverse acceleration component of 3.7 times 10 to the power of -7th astronomical units per day squared. This secondary force acted perpendicular to the radial direction, away from the Sun. Applying the bedrock principle of momentum conservation, the mathematical analysis led to a definitive and sobering conclusion. To generate the observed levels of both radial and transverse acceleration, Comet 3I Atlas necessitated a catastrophic loss of its own substance. The calculations unequivocally indicated that the comet must have shed at least 13% of its entire mass during its intense perihelion passage. 13% represents a violent, not gentle, transformation. This magnitude of material loss can only be attributed to explosive outgassing. Considering the comet's staggering mass, estimated at 30 billion tons, the implications become almost incomprehensible. Shedding 13% translates to the ejection of no less than 4 billion tons of material, a colossal quantity of gas and dust violently expelled into the void of space within a matter of days. 4 billion tons of expelled matter should have generated a spectacular celestial event. The expected outcome would have been the formation of a massive diffuse coma, a giant gaseous halo enveloping the comet's nucleus. A prominent sweeping tail, observable for millions of kilometers, should have streamed from the comet, a visible trail of debris carried away by the solar wind. This is fundamental physics, the predictable consequence experienced by every comet that ventures this close to our Sun. Yet the expected spectacle was absent. On November 5th, 2 independent astronomical observatories situated in Europe captured images of 3I Atlas following its perilous solar encounter.
The Virtual Telescope Project, based in Italy, and the Riemann-Zacco Novice Observatory, located in Spain, both released their photographs simultaneously. The absence of any significant coma or tail in these post-perihelion images constituted a profound astronomical mystery. The comet had vanished from expectation, leaving scientists baffled by its sudden and unexpected invisibility. Both astronomical images presented a strikingly similar initial observation. Each revealed a compact, diffuse spherical envelope surrounding a central nucleus, a small diffuse atmosphere known as a coma. Crucially, neither exhibited any discernible tail structure. The direction opposite the Sun in these photographs is explicitly indicated, a position scientifically termed the anti-solar direction. This is precisely where a comet's tail is expected to manifest, propelled by the combined forces of solar radiation pressure and the relentless stream of charged particles known as the solar wind. According to established models, approximately 4 billion tons of material should be streaming away from the comet's nucleus in this anti-solar direction at this time. Yet, this anticipated plume of ejected matter is conspicuously absent. To appreciate the stark contrast, consider the image of another celestial body, Comet Lemon, captured just 2 days prior on November 3rd by the same RN Novice Observatory instrumentation. Comet Lemon displays a distinct, well-defined tail, precisely aligned away from the solar source. It conforms exactly to the canonical image of a solar system comet. Comet 3 Atlas, however, lacks this defining feature entirely. It does not resemble the expected archetype. Before delving further into potential interpretations of this anomaly, it is essential to acknowledge the conventional explanations currently under discussion within the scientific community.
Some researchers propose that the material expelled during the comet's closest approach to the Sun, perihelion, was predominantly gaseous rather than particulate dust. Such gaseous emissions, while detectable through spectroscopic analysis, can be significantly harder to observe visually against the background of space. Another hypothesis centers on the peculiar viewing geometry. Perhaps the observational angle is such that we are observing the comet's tail nearly edge-on, rendering it effectively invisible to the naked eye or standard imaging techniques. A third possibility centers on the accuracy of mass loss calculations derived from the comet's observed non-gravitational acceleration. It's conceivable that the actual quantity of material ejected was less substantial than current models predict.
However, a critical consideration arises. Each proposed explanation necessitates its own specific set of unusual circumstances. When one is forced to invoke multiple improbable conditions simultaneously to account for a single phenomenon, scientists take very serious notice. The anomaly surrounding Comet 3 Atlas extends beyond this single observation. The 10th documented irregularity stands as a missing piece in a peculiar puzzle. 9 other anomalies exist, each possessing its own independently strange character, each demanding its own unique explanation. Let us examine them carefully. This is not an exercise in sensationalism, but a necessary pursuit to grasp precisely the nature of the phenomenon we face. For regardless of whether this object possesses a natural origin or not, it represents something entirely unprecedented in human experience. Furthermore, the pattern emerging from the accumulating data is, at the very least, profoundly unusual. The first anomaly concerns the trajectory itself. Upon its initial detection on the 1st of July, astronomers promptly commenced calculations to determine its orbit around our Sun. Within a matter of weeks, a distinct characteristic became unmistakably clear. The comet's path through our solar system exhibits an alignment with the ecliptic plane, the vast flat disk upon which all the major planets orbit, to within 5 degrees. At first glance, this degree of alignment might appear insignificant. Therefore, it is crucial to explain the profound implication of this observation. The ecliptic plane represents the fundamental geometric plane established during the solar system's formation 4.6 billion years ago. All the planets, including Earth, Mars, and Jupiter, trace their orbits around the Sun within this remarkably flat plane. This orbital uniformity is a direct consequence of their shared origin. They all coalesced from the same vast spinning disk of cosmic dust and gas that gave birth to our Sun. However, 3 Atlas did not originate within this familiar solar nursery. It arrived from the vast expanse of interstellar space, a domain devoid of any preferred directional axis. There is no universal cosmic flat plane that governs the motion of all stars or incoming objects. Consequently, interstellar objects entering our solar system should arrive from entirely random directions. Their trajectories could be oriented upwards, downwards, sideways, or at any conceivable diagonal angle relative to the established orientation of our planetary disk. There exists absolutely no inherent reason why such a visitor should exhibit any tendency to align itself with the solar system's ecliptic plane. And yet, this particular object does precisely that.
Its trajectory demonstrates a retrograde motion, meaning it moves in the opposite direction to the planets. Yet, it accomplishes this orbital journey almost precisely within the same flat plane that defines our solar system's architecture. The improbability of this celestial visitor's trajectory occurring naturally is staggering, estimated at 0.2%. Statistically speaking, a mere one occurrence in every 500 similar objects. This astonishingly low probability concerning its arrival path constitutes the first anomaly, preceding any examination of its physical makeup or behavior. Its very approach to our solar system defies conventional expectations. The second anomaly manifests in a phenomenon utterly unprecedented in recorded astronomical history, the sunward jet. During the summer months of 2025, a multitude of advanced observatories simultaneously witnessed an extraordinary event. The comet 3I Atlas, instead of ejecting material away from the Sun, as all known comets do, was observed expelling a distinct jet of gas and dust directly towards our star. This contradicts fundamental physics. Cometary tails invariably stream away from the Sun due to the relentless push of solar radiation pressure and the solar wind, which physically displace ejected material outward. Attempting to observe material streaming sunward against this force is as futile as trying to blow smoke directly into the airflow of a fan. It simply does not happen under normal circumstances. While astronomers are familiar with an optical illusion called an anti-tail, where viewing angles make a curved tail appear to point towards the Sun, this was definitively not the case. Experts, well-versed in distinguishing reality from perspective, meticulously analyzed the geometry. Multiple research teams scrutinized the viewing angles and performed rigorous calculations. They conclusively determined that the observed jet represented actual material physically ejected towards the Sun, defying the radiation pressure that should have propelled it in the opposite direction. No known natural comet has ever exhibited this behavior, and no established mechanism adequately explains such an occurrence. The third anomaly compounds the mystery, the combination of mass and velocity. Remember, the nucleus of 3I Atlas measures approximately 5 to 6 kilometers in width, possessing a mass estimated at 30 billion tons. This substantial size, coupled with its observed speed, creates a unique profile that further challenges our understanding of cometary dynamics within our solar system. The sheer magnitude of 3 Atlas is staggering.
This object dwarfs Oumuamua, the pioneering interstellar body first detected sweeping past our Sun in the year 2017. 3 Atlas possesses a mass 1,000,000 times greater than that initial cosmic traveler. Furthermore, its heft surpasses Boros, the interstellar comet identified 2 years later in 2019 by a factor of 1,000 times. But mass alone doesn't tell the whole remarkable story. Speed is equally crucial. 3 Atlas traverses our solar system at a velocity significantly greater than both Oumuamua and Boros combined. This is not a marginal increase in speed, but a substantial leap. This exceptional combination of size and velocity holds profound scientific significance. Interstellar space, governed by fundamental physical principles, statistically favors the abundance of smaller debris over colossal rocky bodies. Large objects are inherently rarer than their diminutive counterparts. Simultaneously, high-speed travelers are even scarcer than their slower peers. Ejecting a substantial object from its birthplace at extreme velocity demands an extraordinary release of energy. Consequently, the statistical models predicting such phenomena converge on a startlingly low probability for detection, less than 0.1%. This translates to a likelihood of 1 in 1,000. The discovery of 3 Atlas represents a direct challenge to these odds. We have now cataloged 3 distinct interstellar objects. The most recent addition, 3 Atlas, uniquely embodies both characteristics deemed exceptionally improbable. It is 1,000 times more massive than its predecessors and moves with significantly greater velocity. While not categorically impossible, such a convergence of rare attributes borders on the deeply improbable, marking 3 Atlas as a significant anomaly. Adding to its peculiarity is the precise manner of its passage through our planetary system. 3 Atlas's journey wasn't merely a random transit. It involved remarkably close flybys of multiple planets at strategically favorable moments. In the 9th month of its approach, it sailed within tens of millions of kilometers of Mars. Coincidentally, the European Space Agency's orbiters were perfectly positioned to witness this cosmic visitor as it passed. Following its Martian encounter, 3 Atlas swung past Venus. Its trajectory then carried it into proximity with the colossal Jupiter. Each planetary approach was close enough to permit meticulous astronomical observation, yet distant enough that the gravitational influence of any single planet failed to significantly alter the comet's overall path through the solar system. Here is the meticulously crafted, expanded narrative preserving all original facts and meaning while enhancing flow and detail. When these extraordinary events transpired, spacecraft were actively orbiting and functioning within the solar system.
The subsequent revelation introduces a remarkable layer of intrigue. The comet's precise arrival schedule exhibited an uncanny alignment. It was meticulously timed so that, during its critical perihelion passage, the moment it reached its closest point to the Sun and would naturally peak in brightness, the celestial body became entirely invisible to observers on Earth. This impossibility arose because the Sun positioned itself directly between our planet and the comet. This placement rendered ground-based telescopic observation fundamentally unachievable. It evokes the image of a calculated itinerary, strategically orchestrating visits to the solar system's primary astronomical monitoring stations while deliberately evading direct scrutiny from the very planet hosting the world's most sophisticated telescopes. The sheer improbability of such timing occurring through natural random processes is quantified at an astonishingly low figure, 5 in 100,000. This represents a probability of merely 0.005%, marking it as a profound anomaly. Turning to chemical analysis, the story deepens. The moment spectroscopic examination commenced on the comet's characteristic gaseous envelope, or coma, an immediate and perplexing discrepancy emerged. The element nickel was detected in copious quantities. Astonishingly, the concentration of nickel exceeded that of iron, a configuration fundamentally antithetical to expectations. In the vast majority of observed comets, if metallic elements appear at all, iron overwhelmingly predominates. Across thousands of documented cometary observations, the established ratio consistently shows iron far surpassing nickel. The three-eyed Atlas comet, however, completely reverses this well-documented pattern. It possesses a greater abundance of nickel than iron, a characteristic pattern typically associated with industrially manufactured nickel alloys, not with naturally occurring icy bodies traversing space. The anomaly intensifies further. The ratio between nickel and cyanide gases present within the coma is elevated by factors of 10, 100, or potentially even 1,000 when compared to any known comet. This includes even the previous interstellar visitor, Boris, which itself exhibited unusual characteristics. This is not a minor fluctuation, but a completely distinct chemical signature. The likelihood of such a composition arising naturally within a comet is assessed as being less than 1%, solidifying it as another significant anomaly. Furthermore, a critical substance essential for comets of its type appears to be strikingly absent. The element water, or its signature compounds, is missing to an extent that defies natural explanation. Comets have long been described as cosmic dirty snowballs, a poetic metaphor, reflecting their fundamental composition.
This high ice content is crucial to their defining behavior. As these celestial bodies journey inward towards the intense heat of the sun, the water ice undergoes sublimation, transitioning directly from solid to gas. This vaporization process releases enormous amounts of dust and gas, forming the vast glowing envelope known as the coma, and propelling the characteristic tails that stream away from the sun. This spectacle is the hallmark of cometary activity, a direct consequence of their icy makeup. However, the object designated 3 Eyes Atlas presents a stark and perplexing deviation from this established norm. Astonishingly, measurements reveal that water constitutes only a mere 4% of its mass. 4%! This minuscule fraction fundamentally challenges its classification. Such a low water content means 3I Atlas possesses remarkably little ice at all. Instead, it appears far more akin to a substantial rocky body, perhaps bearing only the faintest frost-like coating of ice on its surface. This revelation directly contradicts the prevailing understanding of how comets form. According to current scientific models, comets originate in the perpetually frigid reaches of planetary systems, whether within our own solar system or observed around distant stars. These outer regions are characterized by abundant reservoirs of water ice, the essential raw material. Crucially, no known astrophysical mechanism exists that could produce an object of comet-like size possessing such an extremely depleted water inventory. The very process that should forge an icy world seems absent here.
Scientists have meticulously constructed complex models based on thousands of these measurements, allowing them to forecast expected polarization patterns with confidence. 3-eyed Atlas, however, defies all expectations and models. Its measured polarization signature exhibits an extreme negative value, a phenomenon entirely unprecedented in the comprehensive database of comet observations, stretching back through decades of study. This is not a case of minor deviation or measurement error. The signature is completely off the established scale, representing an extreme anomaly that challenges fundamental assumptions about comet nuclei. This single observation, coupled with the low ice content, paints a picture of an object that fundamentally does not conform to the archetype of a comet as we know it. Here is the deeply reworked narrative, expanded while strictly adhering to the original facts and meaning. The comet designated 3I Atlas exhibits an unusual property concerning its reflected sunlight. Astronomers analyzing the light discovered it was polarized in a manner fundamentally inconsistent with established models describing how natural interplanetary dust particles scatter light. This specific polarization signature simply does not correspond to anything observed in typical cosmic dust. Calculations indicate the likelihood of such a polarization pattern arising naturally within a comet is vanishingly small, estimated at less than 1%. Further complicating the mystery is the comet's trajectory. Upon arrival, 3-eyed Atlas originated from a precise location in the celestial sphere that aligns remarkably well within a deviation of only 9 degrees with the direction where the enigmatic WOW signal was detected back in 1977. That historic signal, captured by a radio telescope, was an intense and unexpected burst of radio energy originating from the region of the constellation Sagittarius. It lasted precisely 72 seconds, stood significantly above the usual background static, and its sudden appearance so astonished the astronomer reviewing the data stream that he circled the anomalous reading on the printout and emphatically wrote the word "wow" alongside it. Crucially, this extraordinary signal never repeated, and its true origin remains one of astronomy's enduring puzzles to this day. Is the comet's arrival direction being close to this famous signal's source merely a coincidence? The odds seem surprisingly low. While acknowledging the WOW signal's pinpoint location was never definitively confirmed, and a 9-degree segment of sky represents a substantial area,
roughly 18 times the apparent width of the full moon, rigorous statistical analysis suggests the probability of such a positional overlap occurring randomly is only 0.6%. This low probability adds to the intrigue without providing a definitive answer.
Adding to the anomalies is the comet's dramatic behavior during its closest approach to the Sun. Three-eyed Atlas underwent an unprecedented surge in brightness, increasing in luminosity at a rate that far exceeded any recorded cometary brightening event within the comprehensive observational database. It wasn't merely slightly faster. The acceleration of its brightness gain was profoundly extreme, defying established models that predict how comets typically brighten due to sublimating ices and released gas. Furthermore, during this intense brightening phase, the comet possessed an unusual chromatic quality. It appeared distinctly bluer than the Sun itself. This color anomaly is particularly perplexing because ordinary comets naturally reflect sunlight, resulting in a coloration similar to the Sun's own hue, often appearing faintly redder due to the scattering properties of typical dust particles. The presence of a blue comet is extraordinarily rare in astronomical observations precisely because common dust grain compositions do not possess a mechanism that preferentially scatters blue light more effectively than red light.
Yet the observations present a stark contradiction. Only a compact cloud, the coma, surrounded the nucleus, and no discernible tail structure exists. It is as if the colossal amount of material simply vanished from existence. It is essential to acknowledge this point unequivocally. Each individual anomaly, examined in isolation, possesses potential explanations rooted in known astronomical phenomena. Perhaps the alignment of trajectories was merely fortuitous coincidence. Maybe the observed sunward jet resulted from a temporary, rotational effect unique to that moment. Perhaps the comet's composition reflects an unusual formation history within a different stellar system. Maybe the apparent absence of a tail represents a limitation in current observational capabilities. However, the situation becomes profoundly uncomfortable when considering the totality of the evidence. These anomalies are not isolated occurrences. They represent 10 simultaneous anomalies manifesting within the very same celestial object. When one applies basic probability theory, multiplying the already low likelihoods associated with each individual anomaly, the resulting figure becomes vanishingly small. The chances that all 10 of these distinctly unlikely events would coincide within a single comet are calculated to be less than 1 in 10,000 and potentially even less than 1 in 100,000, depending precisely on the statistical models employed. The convergence of so many improbable factors within one object defies conventional explanation. Here is a deeply reworked, expanded, and refined version of the provided text adhering strictly to all requirements. Harvard astrophysicist Avi Loeb has been vigorously advocating a particular perspective regarding recent astronomical observations. Renowned for proposing unconventional scientific hypotheses, Professor Loeb has specifically suggested that the object designated 3I Atlas exhibits characteristics potentially indicative of artificial origin. While many of his scientific colleagues express significant disagreement with this interpretation, his analytical methodology remains widely respected within the astronomical community. He argues a crucial principle. When numerous independent anomalies, each improbable in isolation, collectively form a discernible pattern, such a pattern cannot be readily dismissed. It is vital to clarify Professor Loeb's position precisely. He is not asserting that 3I Atlas definitively constitutes a spacecraft, nor is he claiming it represents extraterrestrial technology. Instead, his core assertion is that the observed data concerning this celestial object demonstrably fails to align with established natural comet models. Consequently, he emphasizes that this discrepancy warrants serious scientific investigation.
His call is for further meticulous observations, deeper analytical scrutiny, and heightened attention to the specific observational details that present inconsistencies within conventional frameworks. Importantly, Professor Loeb is not advancing this line of inquiry in isolation anymore. The observational data has been made publicly available, enabling other research teams to conduct their own independent analyses. While scientific consensus remains elusive, with some researchers finding merit in Professor Loeb's interpretations and others rejecting them, there exists a clear and growing agreement among astronomers that the object itself is fundamentally unusual and demands explanation. So, what precisely constitutes this enigmatic object, 3I Atlas? What possible explanations exist? The most straightforward, conventional explanation retains the highest likelihood. Scientists propose that 3I Atlas may indeed be a natural comet originating from another star system entirely. Its formation occurred under conditions fundamentally different from those prevalent in our own solar system. This unique genesis could account for its previously unobserved behaviors, simply because humanity has never before encountered an object quite like this. For instance, perhaps 3I Atlas formed around a star possessing a distinct chemical composition, potentially explaining the unusual ratio of nickel to iron detected within it. Alternatively, the comet-forming regions within its parent star system might have existed under significantly different temperatures and pressures compared to our local environment. Such differing physical conditions could plausibly explain its remarkably low water content. Furthermore, it is theoretically possible that we are observing natural astronomical phenomena pushed to their statistical extremes. In this scenario, a rare combination of multiple unusual properties happens to coalesce within a single object, creating the impression of anomalous behavior without requiring artificial intervention.
However, a counterpoint persists, a possibility that often faces dismissal within conventional scientific discourse due to its association with more speculative interpretations. Nevertheless, the peculiar characteristics of these objects, particularly the first detected interstellar interloper, compellingly urge a consideration of this alternative. What if the nature of this object, named Oumuamua, was not purely a product of natural cosmic processes, not necessarily a functioning spacecraft in the familiar sense depicted in science fiction, nor a deliberate probe sent by an advanced civilization as imagined? Yet, could it possess elements of design, direction, and purpose that extend significantly beyond the chance wanderings of matter through the universe? Re-examining its path reveals compelling, almost unsettling details. It entered our solar system with its trajectory remarkably aligned with the flat, disk-like plane where the planets orbit, the ecliptic. It then passed disturbingly close to the planet Mars, precisely as several human-made spacecraft were actively monitoring the region. Its subsequent journey took it past Venus and then skated perilously near the immense gravitational influence of Jupiter, all while it remained completely obscured from detection by Earth-based telescopes at the point of its closest approach to the Sun, perihelion. This sequence of events, occurring with such precision, defies easy dismissal. It feels less like random cosmic chance and more like an intentionally calculated route. Further scrutiny of its physical makeup adds to the intrigue. Its composition registered an astonishingly high level of nickel, a metal significantly rarer than iron in natural celestial bodies like comets or asteroids.
the measured concentration of nickel relative to a compound containing carbon and nitrogen, cyanide, was orders of magnitude greater than anything found in known natural cometary material. This stark contrast is notable, especially when considering that nickel alloys are materials we deliberately engineer for spacecraft construction because of their exceptional strength and resistance to intense heat. Is this composition merely a coincidence, a meaningless statistical blip within the vastness of space? Perhaps it is. Yet the sheer anomaly of its makeup compared to natural objects warrants careful note and further investigation. Finally, the object's water content proved profoundly unusual. At only 4%, this figure placed Oumuamua firmly within the range typical of dense, rocky asteroids, rather than the volatile, rich, fluffy structures we expect from comets. Asteroids are known for their density, hardness, and resilience, characteristics starkly different from the fragile, icy bodies we classically associate with cometary origins.
This combination of an asteroid-like density and an improbable trajectory, coupled with its unnatural metallic signature, forms a complex puzzle that resists a straightforward natural explanation. Choosing a vessel for a cosmic pilgrimage spanning millions of years presents a profound engineering dilemma. Would one construct it from ethereal ice, prone to vanishing into the void, or forge it from the enduring substances of rock and metal? This fundamental question of cosmic durability underpins the mystery surrounding a peculiar celestial traveler. Consider the anomalous sunward jet observed ejecting material towards our star, directly opposing the expected direction dictated by solar radiation pressure. The standard explanation, outgassing driven by solar heating, fails to account for this counterintuitive motion. Could the driving force be something more active, something beyond simple evaporation? The object exhibits other perplexing behaviors that defy conventional natural explanations. It experiences a measurable non-gravitational acceleration, yet shows no visible tail or exhaust plume typically associated with such forces. The implication is stark. The Oumuamua is being physically propelled by an unseen agent. Furthermore, an astonishing quantity of matter has vanished. Approximately 4 billion tons has been detected as missing, but there is no corresponding debris field scattered across its trajectory. The material simply disappears without trace. This constellation of anomalies is not presented as definitive proof of artificiality, but rather as a pattern sufficiently unusual to warrant serious consideration. Science progresses by daring to ask uncomfortable questions, by entertaining even seemingly improbable hypotheses until the accumulated data compels a shift in understanding. Consequently, those who dare to explore such possibilities, like the researcher named Avi, face significant professional criticism. Some colleagues accuse him of sensationalism, of jeopardizing his standing by suggesting that interstellar objects might harbor an artificial origin rather than being purely natural phenomena. Avi's colleague Loa offers a straightforward rebuttal. The data speaks for itself. When multiple independent anomalies, 10 distinct observations, for instance, are clustered within a single object, this does not constitute sensationalism. It represents careful observation demanding explanation. This rigorous approach to data, prioritizing empirical findings over preconceived notions, has become increasingly necessary in light of these strange findings. Recently, this scientific inquiry took an intriguing turn. Loe received an unexpected communication, an email originating from Chile. The sender identified himself as an electrical engineer named Dario Villon.
This unsolicited contact hints at a potential new perspective or line of inquiry emerging from outside the traditional astronomical community, adding another layer of intrigue to the unfolding investigation into this enigmatic interstellar visitor. The nature of Villon's insight or observation remains to be revealed, but it signifies the widening scope of curiosity and the collaborative spirit essential for unraveling cosmic mysteries. The unexpected gratitude arrived from an unusual source. Villain wrote to express sincere appreciation, not for being proven right or wrong regarding the enigmatic object known as 3I Atlas, but specifically for the profound impact of making its story accessible. He credited the effort for inspiring a level of public curiosity that reached even those who had previously dismissed astrophysics as remote or irrelevant. According to Villain, his 18-year-old daughter, who had been profoundly uncertain about her future professional path, found herself reconsidering her direction entirely. Her interest was sparked directly by the analytical explanations provided for 3I Atlas. These explanations succeeded in making the field of astrophysics seem vibrantly alive, laden with genuine uncertainty and compelling mysteries, rather than a collection of settled, unchanging facts. This, Villain emphasized, represented the true value of moments like this one. The significance lay not in settling the debate over whether 3I Atlas originated naturally or was an artifact of intelligence, but in serving as a powerful reminder that humanity's understanding remains profoundly incomplete. The universe, he noted, continues to surprise us. There exist still objects within its vast expanse that defy full explanation. And this very state of the unknown possesses an inherent excitement, a lure for the intellect. Currently, 3I Atlas is engaged in a final, solitary journey. It is moving steadily away from our Sun at a velocity exceeding 200,000 kilometers per hour. By the date of December 19th, it will pass a considerable distance from Earth, approximately 270 million kilometers away. This separation equates to roughly 700 times the average distance between our planet and its natural satellite, the Moon. For a brief window of several days, humanity's most advanced astronomical instruments will possess a singular, final opportunity to observe this remarkable object in unprecedented detail. Beyond that fleeting period, it will vanish from our observational reach. By the year 2026, 3I Atlas will have completely exited the boundaries of our solar system, returning to the cold, dark expanse of interstellar space. Traveling at immense speeds, its trajectory will carry it light-years away from our Sun in a matter of decades.
We will never witness its passage again. No future generation will ever be afforded another chance to glimpse this unique visitor. This encounter represented our singular, irreplaceable opportunity. The legacy of 3I Atlas will reside in the substantial body of data we have managed to collect before its departure. This precious dataset will be meticulously analyzed for years to come. Numerous scholarly papers will undoubtedly be published, dissecting every observation and measurement. New interpretations of the phenomena surrounding 3I Atlas will inevitably emerge over time. Within the scientific community, a lively discourse is already anticipated. Some researchers will vigorously argue that the observed anomalies can be fully explained through conventional astrophysical processes and known mechanisms, seeking to demystify the object within existing theoretical frameworks.
Every instance where humanity asserted a definitive understanding of universal mechanics, we have been compelled to dramatically expand the boundaries of our knowledge. And crucially, each expansion has served as a humbling experience, stripping away layers of assumed certainty and revealing the vastness of our ignorance. Confronted, therefore, with an object arriving from another star system exhibiting 10 distinct anomalies, where each anomaly individually possesses a low probability and all manifest simultaneously, What constitutes a scientifically sound response? Should we consciously or unconsciously attempt to force this perplexing data into pre-existing theoretical frameworks, because doing so offers intellectual comfort and maintains familiar boundaries? Or should we summon the humility to acknowledge a possibility, however remote it may seem, that the universe has presented us with something genuinely unprecedented, something that transcends our current conceptual frameworks and demands entirely new models of understanding? It is imperative to clarify that this perspective does not advocate for credulity regarding extraterrestrial artifacts. Alien explanations remain speculative. Instead, this stance advocates for unwavering intellectual honesty. The measurements obtained from the Atlas object are, unequivocally, strange. This assessment is not subjective opinion. It is a direct consequence of the empirical data. Multiple independent research teams have replicated these findings, confirming the presence of the anomalies. The numerical results are publicly available and verifiable by any qualified investigator. The true debate, therefore, begins not with the observation of strangeness itself, but with the interpretation of that strangeness, determining how we, as a scientific community, choose to engage with and understand these unexpected revelations. Here is the deeply reworked narrative, adhering strictly to your requirements. The ongoing investigation into this remarkable celestial visitor constitutes a vital and entirely appropriate scientific discussion. Genuine scientific progress, however, is never determined by majority opinion. It is fundamentally grounded in a relentless pursuit of tangible evidence, rigorous analytical scrutiny, and a crucial openness to fundamentally reassessing established beliefs whenever compelling new data necessitates such revision. With regard to this specific phenomenon, we possess several unequivocal observations. The entity designated as 3 Atlas stands as the largest interstellar body ever detected crossing our cosmic neighborhood. Its velocity significantly exceeds that recorded for its 2 immediate forerunners. Its chemical signature diverges entirely from any composition previously identified within known cometary bodies. Furthermore, the path by which it traversed our solar system presented an extraordinarily fortuitous alignment, making its observation possible.
Its behavior also included the manifestation of a jet directed towards the sun, a characteristic that fundamentally challenges conventional physical models. During its closest approach to the central star, known as perihelion, it shed a substantial quantity of material, amounting to at least 13% of its total mass. Remarkably, despite this significant loss, it did not generate the characteristic tail typically expected from such mass ejection events. Despite these certain observations, a profound collection of fundamental questions remains entirely unanswered. The underlying reasons for all these peculiar characteristics elude us currently. While researchers propose various explanatory frameworks ranging from more familiar models to highly unconventional ones, definitive answers remain elusive. This state of incomplete understanding is not merely acceptable, it is precisely the fertile ground where science flourishes. It is within this dynamic space, situated between the raw data of observation and the formation of coherent understanding, that genuine discovery takes root. The transmission of the Tianwen-1 images on the 5th day of November will initiate a prolonged period of meticulous analysis lasting for years to come. These preliminary visual records, captured as indistinct monochrome frames from a vantage point within Martian orbit, at a staggering distance of 18 million miles, represent the closest visual inspection humanity will ever achieve of this particular object. Future generations of scientists will undoubtedly apply advanced enhancement techniques to these images, subject them to exhaustive scrutiny, juxtapose them with other relevant data sets, and diligently search for subtle details that may have escaped initial examination. It is entirely possible that these detailed re-examinations will successfully resolve the existing anomalies.
Conversely, they might even serve to further deepen the mystery surrounding this visitor. Regardless of the outcome, these images hold significant value. This is because 3 Atlas is demonstrably not the final interstellar object we will detect. It represents the 3rd such body identified, and it heralds the arrival of many more yet to be discovered. As our detection systems grow increasingly sophisticated and our telescopes attain ever greater sensitivity, the likelihood of identifying additional visitors traversing our cosmic neighborhood intensifies dramatically. Each celestial traveler, upon detection, promises a unique lesson. Each one will inevitably challenge our preconceived notions and force us to reconsider our fundamental assumptions about the nature of space. It is entirely conceivable, perhaps even within our own lifetimes, or certainly those of the next generation of astronomers, that we will achieve a genuine understanding of what these enigmatic objects truly represent.
The central mystery persists. Are they merely the interstellar equivalent of flotsam, random debris ejected from other star systems through complex gravitational interactions, adrift within the galaxy without purpose or direction? Or could they represent something profoundly different, something intentional? Perhaps messages in bottles cast into the vast interstellar ocean, deliberately waiting for astute observers to notice their presence. The answer remains elusive. Yet, what renders this particular moment in history so profoundly remarkable is our unprecedented position. We stand poised to pose this question with genuine seriousness for the first time. Crucially, we now possess the necessary technology to detect these fleeting phenomena. We command the sophisticated instruments required to meticulously analyze their properties. We wield the powerful mathematical tools capable of calculating probabilities and rigorously assessing anomalies. For the very first time in human history, our capabilities extend far beyond mere speculation regarding the profound question of whether we are truly alone in the universe. We can now actively gather tangible data. We can conduct precise measurements. We can rigorously test hypotheses. The crucial data point gathered by 3As, analysis, astronomy, and astrophysics, may not furnish a definitive, conclusive answer. It may remain ambiguous, a fascinating and enduring puzzle rather than a clear revelation. Nevertheless, it has irrevocably moved the conversation forward. It has spectacularly demonstrated that interstellar objects are far more complex, far more varied, and far more surprising than we had initially anticipated. And it has served as a potent reminder that the universe, in its vastness and mystery, owes us no easy answers. The universe operates without regard for human expectation. It simply exists as it is, governed by principles that transcend our preconceived notions. Our fundamental responsibility, therefore, is to observe with meticulous care, to measure with precision, to question with relentless curiosity, and to follow the evidence wherever it may lead. This path may guide us to unsettling conclusions. It may challenge the very foundations of our understanding regarding what is possible. It might even compel us to entertain explanations we would rather dismiss. This, in essence, constitutes the true nature of science. It is not the mere accumulation of established facts, but rather the courageous process of confronting the unknown. It is the intellectual fortitude to acknowledge, "I do not know," particularly when data presents ambiguity, coupled with an unwavering determination to persist in investigation until clarity finally emerges. The 3I Atlas event provided precisely such an opportunity. It presented us with an entity that was genuinely perplexing, something that defied neat categorization within our existing scientific frameworks.
Whether this particular strangeness ultimately signifies exotic natural phenomena operating beyond our current comprehension, or hints at something more profound, remains undetermined at this juncture. However, one fact is unequivocally established. We have directly witnessed something truly extraordinary. We have documented its existence meticulously. We have measured its characteristics rigorously. We have preserved the raw data with the utmost care. And now we must dwell within the sphere of uncertainty, embracing the productive discomfort inherent in not knowing until subsequent advancements in data collection or theoretical development provide the necessary illumination. This is our current position in the month of November 2025. We stand observing an anomalous object as it departs our solar system, carrying with it a burden of questions that far outweighs the answers we possess. It serves as a powerful reminder that the cosmos possesses a strangeness and a wondrous complexity that exceeds the capabilities of our current models to fully capture. The object remains observable through the lenses of large telescopes. It continues its trajectory at a velocity of 129,000 miles per hour, relentlessly racing back towards the vast interstellar void from which it originally emerged, leaving behind a trail of profound inquiry in its wake. Here is the deeply reworked narrative, expanded to enrich the original while preserving every fact and meaning. The scientific community currently possesses only a limited window of opportunity remaining for observation. This precious time may extend for several weeks, or possibly even a few months. Within this period, dedicated research teams continue their intensive work, meticulously gathering every available data point, rigorously running complex analyses, and striving desperately to extract any final crucial insights from these fleeting celestial visitors before their light-years journey through our solar system concludes permanently. What their efforts ultimately reveal may not provide definitive answers to the central debates surrounding these objects. Instead, the findings could very well introduce a cascade of new, perplexing questions into the existing scientific discourse. This outcome, however, is entirely acceptable. Far from being a setback, such unanswered questions represent invaluable assets. They serve as powerful engines driving scientific progress forward. They act as essential safeguards against complacency, compelling researchers to maintain rigorous standards and ensuring our collective understanding of the universe remains honest and continually refined. It is this inherent value of inquiry that underscores the extraordinary significance of our present moment. We are, without question, living at the very genesis of interstellar object astronomy.
This nascent field stands at its absolute infancy. We remain far removed from its mature phase. Reflect upon our position merely 8 years ago, before the historic detection of the first such visitor, designated Oumuamua. Interstellar objects existed solely as theoretical constructs within astronomical science, while scientists possessed a firm conviction based on stellar system formation models that these bodies must inevitably exist, ejected during planetary system assembly and silently drifting through the vastness of the galaxy for eons. We had never directly observed or studied one. Our knowledge was nil, devoid of any empirical data, lacking even the most basic measurements, and offering no understanding of their physical appearance or behavioral patterns. The transition from this state of total ignorance to our current reality represents a monumental leap. We now possess 3 distinct data points, where previously there had been precisely 0. Furthermore, each object encountered has defied initial expectations in profoundly unexpected ways. The first visitor, Oumuamua, presented baffling characteristics. It exhibited an unexplained acceleration that lacked the telltale signature of visible outgassing, a common feature in cometary activity. Its tumbling motion was erratic and did not correspond to any rotational behavior previously documented for known celestial bodies. Tragically, its rapid trajectory carried it away too swiftly for comprehensive study. The second object, Boris, offered a semblance of familiarity, appearing and behaving more conventionally as a comet. Yet even this seemingly familiar visitor possessed its own anomalies, notably displaying unusual concentrations of carbon monoxide. The third object, designated 3I/Atlas, has presented an extraordinary array of scientific puzzles, with 10 documented anomalies complicating its profile. Studying 3I/Atlas has proven particularly challenging due to its observations being captured from the orbit of Mars, resulting in only fuzzy images providing limited detail. Thus we stand with 3 distinct interstellar visitors, each embodying its own unique enigma and mystery. This burgeoning field of study, gathering its first breaths of empirical data, is only truly beginning to take shape. Here is the deeply reworked and expanded version of the text, adhering strictly to the guidelines. The dawn of a new era in astronomy is imminent. The next generation of powerful telescopes promise unprecedented sensitivity, fundamentally enhancing our ability to probe the cosmic depths. Central to this advancement is the highly anticipated Vera Rubin Observatory, poised to commence its groundbreaking operations in the near future. This revolutionary facility will systematically map the entire visible sky with astonishing frequency, conducting a complete survey of the celestial sphere every few nights.
Such relentless vigilance will reveal celestial bodies previously beyond our reach, objects of extreme faintness, distant galaxies on the edge of detection, and even phenomena moving along trajectories that elude current observational surveys. Conservative scientific projections indicate that, once fully operational, the Rubin Observatory might detect approximately 1 interstellar object annually. However, more enthusiastic calculations suggest the actual count could substantially exceed this initial estimate. This potential surge in discovery means that within the span of a single decade, humanity could catalog 10 or 20 distinct interstellar visitors. Extending the timeline further, within 2 decades, the number could well reach into the hundreds. Each of these objects represents a solitary traveler drifting through the void between stars, hailing from another stellar system entirely. Every interstellar object discovered serves as a unique messenger from across the immense distances of interstellar space. These bodies are, quite literally, foreign entities. They are not necessarily imbued with biological life or intelligence. Their alien nature lies in their profound geographical and temporal separation. Each specimen formed under conditions distinct from those within our own solar neighborhood, sculpted by processes operating in a different cosmic environment, and potentially composed of materials whose existence remains unknown within our local system. The significance of these visitors cannot be overstated. They offer us untainted samples, direct specimens originating from worlds and star systems we will never physically explore. Each carries within its structure the chemical signature of its birthplace, the elemental fingerprints of its parent star, and the planetary nebula from which it emerged. Furthermore, its surface bears the physical scars accumulated over an epic journey lasting millions or even billions of years, scars etched by cosmic collisions, radiation, and the relentless passage through the interstellar medium. In essence, it delivers a tangible fragment of another star system's history. For this fleeting moment, as one of these cosmic travelers traverses our solar neighborhood, we are granted a singular opportunity. We possess the rare chance to examine and decipher the story it carries, a narrative written in minerals and isotopes, a chronicle of formation, evolution, and survival across cosmic distances. The recent discovery, designated as 3 Atlas, stands as a particularly intriguing chapter within this unfolding saga. It presents us with a strange, perplexing, and profoundly provocative specimen. Its characteristics raise far more questions than they answer, igniting scientific curiosity and underscoring how much remains unknown about the myriad worlds that drift among the stars.
The current moment in astronomical investigation is far from a conclusive endpoint. It represents merely the opening pages of a significantly longer narrative. The precise measurements and observations gathered today will fundamentally shape our comprehension of every subsequent visitor from beyond our solar system. Every anomaly meticulously documented now will evolve into the foundational bedrock for entirely new scientific theories. The very questions posed during this initial phase will directly determine the structure and direction of research endeavors for decades to come. Furthermore, as the collected dataset inevitably expands through the discovery of additional objects, a critical process will unfold. Discernible patterns will begin to crystallize. This growing body of evidence may reveal one profound possibility: that objects resembling the 3-eyed Atlas are in fact relatively common occurrences within the cosmic landscape. In this scenario, the very first 3 such objects detected which stand revealed as unrepresentative outliers, mere statistical flukes in the grand scheme. Conversely, the data might suggest the complete opposite, that the vast majority of interstellar travelers are, in essence, mundane rocks and frozen spheres of ice. If this proves true, then the 3-eyed Atlas would achieve even greater extraordinary status, distinguished precisely by its deviation from the norm. At this present juncture, the ultimate outcome remains a profound mystery. Absolute certainty has not yet been attained, yet this very uncertainty defines the exhilarating promise inherent in this nascent field of astronomy. We exist in an era not bound by idle speculation about hypothetical celestial phenomena. Instead, we are actively engaged in the crucial work of witnessing, observing, and empirically documenting what actually inhabits the vast interstellar space. We're quantifying its properties, debating interpretations, and constructing our understanding based on tangible evidence. And within this rigorous process, there lies the potential for genuine surprise. The data may occasionally present us with phenomena we fail to predict, challenges to existing models that resist easy explanation, forcing us to expand our conceptual frameworks regarding cosmic possibilities. The 3-eyed Atlas embodies precisely this kind of unexpected revelation. Whether its origins are ultimately traced to an exotic natural phenomenon or perhaps something more enigmatic, this object has undisputably pushed the boundaries of human knowledge. It has compelled us to re-evaluate assumptions we previously held unconsciously within the very foundations of our scientific reasoning.
Most importantly, it serves as a powerful reminder. The universe operates without any obligation to conform to the limitations of our current understanding or the parameters of our familiar existence. Its truths are discovered, not dictated.
It is an acknowledgement that despite our technological prowess, we remain nascent learners, still mastering the fundamental lexicon of cosmic phenomena. We are actively constructing the essential conceptual frameworks, the foundational theories and instruments, which will ultimately grant us true comprehension of the astonishing sights unfolding before us. Yet woven intricately with this humility is a palpable thrill, a surge of excitement. For if the universe demonstrated such profound capacity for astonishment with merely 3 confirmed interstellar interlopers, what staggering revelations await us from the next 100? What breathtaking discoveries lie hidden within the unfolding chapters of the next decade, the next generation of explorers, the next century of relentless inquiry? At this very moment, somewhere within the vast, dark expanse of interstellar space, another celestial traveler journeys inexorably towards our solar system. Perhaps it already traverses the cold, distant reaches within Neptune's orbit, obscured by its sheer faintness or intercepted by the angles of our telescopes. Perhaps its arrival remains shrouded in the future, delayed by another 10 years, 50 years, or even 1,000 years. But it approaches. They all approach. The galaxy teems with these nomadic entities, and inevitably, a minuscule fraction will drift through our own cosmic neighborhood. Each arrival constitutes a precious opportunity, an invitation to acquire new knowledge, a crucible for testing our carefully constructed theories against the raw reality of the cosmos, a guarantee of potential surprise. And perhaps, just perhaps, one of these objects will defy all expectations entirely, manifesting such profound anomaly that it compels us to confront a question we have skillfully sidestepped for generations. Are we truly alone? This unspoken, underlying query permeates every analysis of the 3 interstellar objects, every meticulous examination of their chemical signatures, every complex calculation concerning their improbable trajectories, every debate surrounding the perplexing absence of a cometary tail. It is the fundamental question resonating beneath the surface of every scientific discussion, the central mystery we all ponder in the quiet moments, though most hesitate to voice aloud. The potential answers, when they come, will undoubtedly redefine our place in the universe. The question inevitably arises, could patterns of inexplicable phenomena observed in our solar system potentially hint at forces beyond known natural mechanisms? Specifically, the simultaneous occurrence of 10 distinct anomalies, each statistically improbable in isolation, demands profound consideration. Could such a cluster constitute a deliberate signal amidst the cosmic background noise, rather than mere random fluctuations? It is vital to emphasize that I am not asserting this as fact.
However, intellectually, we must prepare for the possibility that one of these interstellar visitors, objects traversing the void between stars, might in reality be artificial in origin. Imagine encountering a probe, a deliberate messenger, or fragments of abandoned technological sophistication, crafted with intentionality, not merely the result of countless random collisions and gravitational dances. The day such an encounter occurs may not transpire within our own lifetimes. It is entirely possible that it may never occur at all. The universe could indeed be saturated with natural marvels while remaining utterly devoid of any artificial constructs. And that profound conclusion,
the absence of artificiality, would stand as a valid and scientifically credible answer to the age-old question of solitary existence. Yet if that pivotal moment does arrive, if detection confirms the presence of an object genuinely artificial gliding through our solar system, the critical initial phase will involve its definitive recognition. This recognition hinges upon posing the correct investigative questions, upon developing robust analytical instruments capable of distinguishing the artificial from the natural, and upon fostering an intellectual environment willing to entertain explanations that initially seem implausible until overwhelming data compels their acceptance. The specific case referred to as 3 Atlas might not represent that singular artificial object. Probability suggests it is likely not. Nevertheless, the research and analysis surrounding such events are imparting essential skills. They teach us how to observe, how to analyze data with heightened scrutiny, and crucially, how to contemplate interstellar visitors not merely as astronomical curiosities, but as potential vectors of artificial intent. This ongoing process is effectively training humanity for whatever enigmatic phenomena emerge next, because they will emerge. Another object will cross our field of view, another mystery will present itself, another data set will challenge our current comprehension, and then another, and another. This sustained sequence of discovery and challenge is becoming the established norm within the field of astronomy. The era of merely theorizing about objects traversing the vast gulfs between stars is definitively over. These celestial wanderers have transitioned from abstract concepts into tangible realities, observable by our instruments, measurable with scientific precision, and analyzable through rigorous study. Humanity now stands on the threshold of encountering such visitors with regularity, a pattern that will likely persist throughout the entirety of our species' recorded history.
Children born today will inhabit a fundamentally different cosmic landscape, one where the arrival of interstellar travelers becomes as commonplace a feature of the night sky as comets were in previous generations. Their education will include detailed accounts of 3 distinct atlas objects chronicled within the pages of their textbooks. Museum displays will showcase the iconic 10-Win-1 images, grainy black and white records of a peculiar, tailless, fuzzy sphere. History lessons will recount the significant controversy surrounding the 10 distinct anomalies detected in the year 2025. Anomalies that sparked intense scientific debate. It is entirely possible that by the time these young minds mature, some answers will finally emerge. Perhaps the enduring mystery will be unraveled, the anomalies fully explained, and the academic discourse finally settled. Yet, the alternative possibility remains equally poignant. Perhaps the enigmatic nature of Oumuamua, this strange comet that defied every known classification system and vanished before its secrets could be fully probed, will endure. It may persist as an unsolved riddle, a fascinating puzzle left to us from the pioneering days of interstellar object astronomy. Regardless of the outcome, the significance of our current actions resonates deeply. It matters profoundly that we meticulously documented its passage. It matters immensely that we dared to pose the most difficult, unsettling questions about its origin and composition. It matters crucially that we preserved every piece of collected data for scrutiny far into the future. This is the essence of cumulative science. Every single observation, no matter how perplexing, forms a vital building block upon which all subsequent discoveries are constructed. Every mystery that remains unresolved today transforms into a crucial clue for researchers living decades, perhaps even centuries from now. These future scientists,
equipped with incredibly sophisticated instruments and possessing theories far more complete than our own, will revisit our findings. The 10-Win-1 images, those slightly blurred monochrome captures of an unfamiliar, non-tailed object, will become foundational study material for scientists yet unborn. They will apply image enhancement algorithms of unimaginable power to those old frames. They will compare them against databases encompassing hundreds of interstellar objects, identifying subtle patterns and correlations that currently lie completely beyond our perception. Their perspective, sharpened by technological leaps we cannot yet conceive, will inevitably shed new light on the enigmas we are only beginning to grasp. The enigma of 3E Atlas lingers, a celestial puzzle we continue to ponder. Perhaps future inquiry will finally illuminate the profound mysteries this interstellar visitor revealed during October and November of 2025.
Why, then, did this comet manifest such extraordinary anomalies? Why did billions of tons of ejected primordial matter leave no detectable trace upon the cosmic stage? For now, we remain suspended in uncertainty, our minds engaged in relentless analysis of the precious data we possess. We stand ready for the next wanderer from the stars, and we pause to reflect upon the staggering immensity, profound antiquity, and inherent strangeness of the universe, realms that stretch far beyond our present understanding. 3I Atlas originated from distant depths, potentially from a star system situated hundreds of light-years away, circling a sun we shall never behold, forged from materials and conditions existing in realms we can only conjecture. For countless millennia, it traversed the silent void, enduring the numbing cold near absolute zero, threading through hazardous radiation fields and immense gravitational wells. Throughout its odyssey, it carried within its frozen heart the unique chemical signature of its distant birthplace. Then, for a fleeting moment, spanning a few brief months in the year 2025, it crossed the threshold of our solar system. It drew perilously close to the rugged terrain of Mars, skirted the scorching expanse of Venus, and approached the colossal presence of Jupiter. Its closest approach to our life-giving star occurred at a distance equivalent to 9/10 of an astronomical unit. Here, then, was the comet's final act, subjected to searing heat, violent outgassing that ripped through its structure, and forces so immense they would have shattered the cores of most known comets. In a matter of days, it surrendered 13% of its very essence, shedding mass into the cosmic expanse. And then, propelled by unseen forces we could only measure, it departed our system, accelerating away into the abyss of interstellar space. Its velocity became such that within the span of our own lifetimes, it will carry itself light-years beyond our reach. We were granted but a single glimpse, a singular opportunity. China's ambitious Tianwen-1 mission captured the closest images humanity will ever obtain of this alien traveler. Simultaneously, ground-based telescopes diligently documented and chronicled its altered state following its fiery passage through the solar system's heart. The precise instruments of spectroscopy meticulously examined its composition, revealing the celestial traveler's forgotten secrets. Simultaneously, mathematicians dedicatedly calculated its intricate trajectory and precise acceleration, mapping its path through the void. And now this remarkable journey concludes. The venerable probe known as 3I Atlas is departing our solar system. By the time you hear this account, it may already be far beyond the orbit of Mars, gliding outward into the cosmic expanse. Each passing day sees it grow fainter, more elusive, its light diminishing against the backdrop of distant stars.
In the 26th year of the 21st century, it will cross the final threshold of our solar system, forever returning to the vastness of interstellar space. It will continue sailing through the galaxy's deep sea, perhaps for another 1,000,000 years,
or even a billion, until some gravitational dance alters its course, or some cataclysmic collision brings its existence to an end. Yet, vital information remains preserved: the captured images, the precise measurements, the detailed spectroscopic analyses, the complex trajectory calculations, all meticulously archived. This invaluable collection of data stands ready for future researchers, ready to be studied, questioned, and reinterpreted in light of discoveries yet to emerge. This is the essence of scientific endeavor. We strive to chronicle the cosmos as comprehensively as human ingenuity allows. We take measurements. We safeguard data. We pose probing questions. We acknowledge the boundaries of our current knowledge, and we persistently continue our search. Keep observing. Keep striving to comprehend. 3I Atlas Telescope gifted humanity something infinitely more valuable. It reignited our capacity for awe through genuine scientific inquiry. It bestowed upon us profound, substantive questions, questions grounded firmly in empirical science and rigorous observation, questions that will form the cornerstone of astronomical research for decades to come. The data it gathered didn't merely confirm our established beliefs, it actively challenged them, forcing us to reconsider long-held assumptions about the nature of our surroundings. More importantly, it offered a profound glimpse into the sheer magnitude of our ignorance, a vivid reminder of how vast the frontier of understanding remains.
In this process, it restored a fundamental purpose to our cosmic gaze. We look upwards not with the naive expectation of readily finding answers, nor because the universe is obligated to our comprehension. We look upwards because the questions themselves ignite our innate curiosity. We pursue understanding not because it is owed to us, but because the very act of seeking knowledge, the relentless pursuit, is the defining characteristic of our humanity. It is the spark that illuminates our place within the grand scheme. As the 3A's object, having completed its remarkable mission, gradually recedes beyond the reach of our earthly instruments and returns to the silent expanse between the stars, we are left with its enduring legacy, the questions it unearthed. 10 documented anomalies whisper of previously unrecognized phenomena. One mysterious interstellar visitor, a non-native traveler from the cosmic highways, stands as a testament to the universe's capacity for the unexpected. And within this legacy resides an unshakable certainty. Countless more such surprises are yet to come. The next chapter of this unfolding cosmic narrative is already being written. Another interstellar object, journeying silently through the profound darkness between stellar systems, is already in motion. It carries its own unique cargo of mysteries, unknown properties, and potential surprises, its ultimate nature still shrouded in uncertainty. We are unaware of its identity or its secrets, but that state of knowing is temporary. We possess the instruments, the sensitive eyes of our telescopes, the precise tools of our analysis. We have the relentless curiosity that drives us to seek and the determined spirit that refuses to yield. When that next unexpected visitor arrives, bearing its alien signature across our solar system, we will be prepared. We will document its journey with meticulous care. We will analyze every photon, every spectral line, every movement with the sharpest tools at our disposal. We will pose the difficult, probing questions that unravel complexity, and we will preserve the data, ensuring it becomes a foundational record for future generations.
Their interpretations may reshape our understanding in ways we cannot yet envision, building upon the questions we posed and the mysteries we began to unravel. Here is the deeply reworked narrative expanding upon the original text while preserving its core meaning and spirit. This marks the dawn of a profoundly new chapter for the field of astronomy. It is not a chapter promising definitive answers, nor one offering comforting certainty. Instead, it opens with a chorus of vital questions, a commitment to relentless discovery, and the exhilarating realization that the shroud of cosmic mystery remains, but is finally beginning to lift. Within this unfolding era stands the remarkable presence of the 3A's object.
Its nature was undeniably strange, fundamentally anomalous, utterly unprecedented in recorded history, and above all, consistently, breathtakingly real. We bore witness to an event profoundly extraordinary. We meticulously documented its passage and its peculiar characteristics. Now, propelled forward by this singular encounter, we carry these invaluable questions within us, prepared for the unknown possibilities that lie ahead. The significance of this moment is immense. Within our own galaxy, at this specific juncture in human history, we have achieved a unique position. For the first time, we possess the capability to observe beyond the confines of our own solar system. We can receive natural visitors traversing the immense gulfs between stars. We can study materials and physical processes that simply do not exist within our immediate cosmic neighborhood. It follows, inevitably, that some of these visitors will be profoundly strange. They will challenge our established scientific models. They will display behaviors utterly inexplicable by our current understanding. They will compel us to radically expand the boundaries of our thinking. This, however, is not a sign of failure, but rather the most potent opportunity science could desire. Therefore, we raise a toast to the 3A's object, the mysterious visitor from another star that arrived among us. It defied easy categorization. The comet that wasn't quite a comet. The object that astonishingly shed 13% of its mass, yet displayed no characteristic tail. The enigmatic anomaly that ignited 1,000 debates within the scientific community and will fuel research endeavors for decades to come. We will not see this specific visitor again, but its profound impact will undoubtedly be remembered for generations. And somewhere, out there, within the vast inky darkness that separates one star from another such visitor is undoubtedly on its journey. We stand ready. We will be watching.